All right. Well, welcome everyone. We're going to go ahead and get started today. So again, I want to thank everyone, all our attendees for this, you're joining this webinar series today with peer air filtration. So today we're going to ask the expert. So we have a world-renowned gentleman. We have an IAQ discussion with Mr. Barney Burroughs. So just a little bit of background on Barney. He's going to be our featured guest for this month's technical interview. And he is currently on staff with Pure Air as an advisor and consultant for our leadership team. Barney is best known recently for his technical background and experience with IAQ and related high-end filtration and air cleaning technologies. This is because he is past president of ASHRAE, chaired the committee that created the MERV testing method, co-authored Managing Indoor Air Quality, the textbook on IAQ, and wrote the peer-reviewed 100-year history of filtration and air cleaning. And I was just had the great pleasure of finding out the start of his name, H.E., that is His Eminence. So with that said, we're going to go ahead and get started. Mr. Barney Burroughs.
Thanks too. With people wanting to know what the HE stands for, because I've done business that way my whole life, but being known personally as Barney. And I did find out that virtually all the special buildings in the Pacific are named after His Eminence, His Excellency, and Her Majesty, something or other. And so I decided that that's what the HE does stand for in my case. And so I wear that honor well. Along with this hat, and I apologize for you for wearing a hat, but I do it for three reasons. The first reason is that I've worn a hat for the last 20 years, and I have about 20 or 30 of them, and so I'm known to be the man with the hat. Secondly, I do it because my doctor told me I had to. But but thirdly, it appears to make me stand taller. And so I'm accepting that explanation as it makes me taller.
Excellent.
Well, I'm glad to be here with you today. The opportunity is that we can dig into some pretty basic issues that we need to deal with. And I'd kind of like to start there.
Okay. So, okay, well, Barney, so what I can do from there, I'll have a start with a good question, but let me go back just a little bit. Wanted to introduce Pure Filtration a little. We got some very exciting news as a company. We were recently acquired by Clean Water One. So the fantastic organization. It's really going to help Pure Air Filtration grow and reach new heights. So I wanted to start off with that. So Barney, thank you for allowing me to jump in. So okay, now we continue with the kind of with the first question regarding IAQ. So I just wanted to know, Barney, what is IAQ? What is the IAQ issue all about? And what are some of the misconceptions about it that affect our understanding of acceptable air quality solutions in commercial buildings versus industrial manufacturing facilities?
Well, let me thank you for starting us there, because what I think we need to do in this discussion is dig into some basic concepts that are part of the process of understanding some misconceptions that still pervade in the industry. And it's something that I think our viewers and participants today would appreciate in terms of background. The important thing is to understand that air is air is air. And by that, I need to say the whole issue of understanding indoor air quality is first to understand what air is. And it's as a component to our environment and our lifestyle and our life experience. It's important to know what it really is. And the baseline of air, wherever it is, whether it's outdoors, meaning ambient or environmental air, indoors, indoors in a hospital or indoors in a school, it's all air. And it's made up of the same components in the same proportions as any other air on the globe. It's basic. It's just about almost 80%, 79 to be precise, of nitrogen. Oxygen is about 21%, maybe a percent of argon, and just a fraction of carbon dioxide in the 400 parts per million range as far as concentration. And it's the same whether it's a manufacturing facility or a commercial building. So it's important to understand that, and because much of the misconception is that air is different, and so are buildings different. But actually, it is the air that is the same regardless. And what happens to make it become an indoor air quality issue is that same basic content gets altered by where the pathway of the air goes. So we have basically an airstream in our built environment that starts outside. It goes from outside and literally is either blown or sucked into a building where it meets and comes in contact with occupants. Those occupants are basically surrounded by their own individual environment. That includes cosmetics, it includes bodily functions, it includes skin shed and cells and that sort of thing. We're coming in contact with their activity, what they do within the building that may or may not be purposeful, but if it is purposeful, then there are possibly outcomes from that in a sense give us hitchhikers, basically, that become part of that airstream. And as we finish that pathway through the building, we also discharge it and put it back into the outdoor environment with everything that it has gathered as hitchhikers along the way, suddenly to become perhaps the indoor air that is supplying the neighbor's building. So that pathway, in a sense, is what is changing the nature of the air, even though the basic air remains the same. So it's not different buildings, commercial versus industrial, for example, and it's not different air. It's the same air. It's just the folks that have been tagging along. And that is kind of setting the stage for us. So the misconception first is that it is all the same air. It is what we have to deal with as hitchhikers. From basically that simple generic description of the air, we talk about more and more hitchhikers as they accumulate. The one that is probably stable and constant with all of them is, in fact, moisture, because moisture also, starting out as a liquid, goes into gas phase and becomes a passenger in that airstream. So conception number 2 is that we're getting a more and more complex issue as we introduce moisture into the environment through that process. Now, at the end game, the historical mantra, as it were, for solving matters as complex as indoor air quality is that pollution, which are basically those gatherings as that pathway goes through the building, they, in a sense, need removed. And what is the most practical and simplistic way to do that? Well, the mantra was pollution is resolved by dilution. So the solution to pollution is dilution. Now, again, and the last misconception really is that pollution can be and will be always best resolved by ventilation, which is the dilution. And so that's misconception number 3 that still plagues us as we go into resolving the more complex issues that IAQ really does represent. So that sets the stage for us, Anthony, that I've made my point about these residual misconceptions, but to go ahead and address the specifics, I think it's important for us to address kind of the learning curve that we've gone through and to, in a sense, look at the history of IAQ so we understand how we got to where we are today in the 21st century.
Sure. And with that, Barney, obviously you began this journey decades ago. So kind of, looking back, what would you say, what kind of were the major turning points or influences that reflect the historical learning curve of addressing indoor air quality issues, and also at the same time, just kind of emphasize those roles, the role that regulation played in that as well. Can you talk about that a little bit?
Well, in fact, Anthony, I can talk about it a lot because what I want to do is, in a sense, tell the story of IAQ while I tell the story of the filtration industry. And along the way, I'll confess to some participation in a good part of the development and history of what we call the HVAC industry. I want to start us back in the original history, which will demonstrate perhaps how long I've been involved with indoor air quality. Because we're going to start in WW2. Because towards the end of that adventure, we invented the absolute filter. The HEPA filter was created in the latter years of that adventure by the Manhattan Project that was turning out what we basically terminated the war with, was the atomic bomb. And the HEPA filter was basically created for the benefit of avoiding worker exposure to radioactive iodine that had a nasty habit of being able to go from gas phase immediately into a solid particle. It basically jumped state and could condense out of gaseous content and radioactivity into an inhalable particle. So the HEPA filter was created for the purpose of protection from that radioactivity. And of course, the same consequence as all of the victims of exposure to the atomic explosion process. And interestingly enough, the test method was developed then that identified 0.03 micron sized particles as the smallest necessary particle to measure, because it was the most that could be measured still, and yet it was the smallest particle that would need to be retained in any great efficiency. So that test method, which became known as the DOP, dioctylphthalate test method, received the first Nobel Peace Prize awarded for technology in the HVAC industry in 1946. And so that Peace Prize and that test method, which became a military test, is still in place as test method 209, a military test method, and it started the technology of the filtration industry. Well, with that mighty start and boost, as it came out about, the filtration industry went ahead and manufactured and marketed that filter under the brand name Absolute. And by the 60s, it was being widely used in special filtration areas of special needs and was administered by the Atomic Energy Commission. It was commercialized then, and to do so, we had to work around the name Absolute because that was the original trademark of the first manufacturer. And I was even on the naming committee that came up with the name High Efficiency Particulate Arrestor that became the HEPA that we know today. So HEPA became the start of the high efficiency kind of filtration used on into the end of the century. That was immediately enhanced by Dwight Eisenhower, president at the time, who fostered the Hill-Burton Act. And the Hill-Burton Act basically funded the care facility construction of hospitals in every county in the United States to make available health care free to citizens who were either indigent and could not afford health care, but specifically designated to take care of the wounded soldiers returning from WW2. The interesting thing is the Hill-Burton Act started and built in to all those healthcare facilities high efficiency filtration. And that additional impetus on top of the technology from the Manhattan Project basically started the filtration industry of particulate control in healthcare facilities and in similar structures. Well, by the 60s, with that underway, I founded a firm called Purifil. And I had the privilege of holding in my hand in 1967 the first manufactured permanganate-based sorbent based on the patents that were issued for the first chemisorbent that was produced and marketed, and that started the gas phase portion of filtration. You're going to have to interrupt me for just a minute. I need a drink of water, and I'm going to do that if you'll forgive me just a moment.
And absolutely no problem. Very interesting information. Very knowledgeable.
If you'll excuse me for just a moment, a sidebar. My notes are not up here. I'm having to work on this. I didn't realize that.
No problem. No problem.
Let me do that. Thank you. It was not long after I founded Purifil that simultaneously, and I did that in Atlanta, Georgia, where we are still today. So it is interesting that I'm here in the halls of pure air filtration, not 2 miles from the original Purifil site that was just down the way. So we've repeated a bit of history here in my being in this office on this day, enjoying the culmination of growth. So by the time we're into the late 60s, simultaneously to all of that, the enhancement that made all of this possible was the development of a, a basically a entire industry of self-contained air conditioning, both packaged and engineered. These systems made it possible for acceptable environments to be attained in the south and southwest of the United States, and it, in a sense, opened up those markets for residential, through educational, through commercial, through manufacturing facilities, and it became boom town in the southeast, which opened up an entire new marketplace for construction. That growth factor basically gave the impetus to the HVAC industry to move forward in almost total requirements for air conditioning as an industry. So not only are we seeing filtration grow itself, but as a part of the HVAC industry. Well, when those things were going on, we simultaneously had in 1970 a requirement to look at that growth, because the heavy industry was developing. We had pulp and paper mills. We had Birmingham was filled with steel mills. We had those kinds of heavy industries that were bringing environments that, if you remember me talking about, had piggybacked these contaminants within the air and environment in the workplace. So the workplace, which was heavily industrial at the time, became issues of environmental control for life safety and conditions. So 1970 brought on OSHA, which was part of the Labor Department, and NIOSH, which was created under the Public Health Department. And you may not know, public health was a part of the Department of Navy, because of the health of sailors prepared the way for public health to be addressed to take care of the returning sailors and their families. At the same time, EPA was addressing the environment that was being affected by the pollutants coming from these processes. They, in turn, were created by and managed the Clean Air Act of 1970 and the Clean Water Act of 1972. So here we have a management of these environmental issues, and here we sit today with a combination of the new pure air, which is both water and clean air. So it is an interesting marriage made in 1970. The oil embargo that happened soon thereafter added even more fire to the issue of clean air, because OPEC, out of spite and control of the energy environment, created an embargo against a U.S. and the U.K., as well as the Netherlands, and cut off our energy supply. Our oil was embargoed. That affected us for the next decade in terms of the inflation and recession that occurred, and the increase in prices that doubled or tripled overnight. So that created stress for the product of oil, which is fuel and electricity. An immediate response to that was that the DOE, Department of Energy, was created. And in 1977, they imposed an imperative insulation requirement for residential properties and especially manufactured housing. This manufacturing housing, which was basically house trailers, employed very, very extensive urethane type and formaldehyde type catalyst foams. Those outgassed free formaldehyde, which became both as an allergen and as a carcinogen, caused tremendous health effects with residents and created the first declared indoor air quality incidents. And these resulted in litigation, and by the end of the decade, indoor air quality had been established as a concern. Now, where we've ended up is through a process of basically regulations, litigation, legislation. We have ended up with an indoor air quality industry that was basically responding to the stressors of these influences. And that newly created energy department brought about a reaction by building holders that ended up being tightening their buildings, closing their buildings down from the use of that dilution process that we talked about earlier, the ventilation air. And that ended up with the exaggeration of indoor air quality out into the concern called tight building syndrome and sick building syndrome that was ending up in the net effect of a industry-wide concern over indoor air quality in all public buildings. Now, in the meantime, while this was all going on, industry itself was going through a process of dealing with their own indoor air quality issues. But in that instance, there was not the health effects that were being involved. It was truly the dealing with acid gases. And acid gases such as sulfur-based, chlorine-based, would attack computers because in the development of HVAC and so on, control rooms were designed with conditioned air, and as a process of the air conditioning, it confined the space into environments that were not conducive to computers. So while the health effects resulting from commercial buildings was an outcome, the outcome in industrial space became basically plagued by very, very costly downtime, a costly reproduction and replacement of computer equipment, all subject to corrosive levels at a microscopic level. So these two areas of indoor air quality tracked each other well into the 80s as these processes are going on. By the end of the decade, the building owners were really reacting to energy conservation, and this ended up pulling in a new player into the indoor arena, and that was ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers. And then that was a much more formal entry for a technical society that took over the whole area of air control and air quality. They substantially took the leadership and took over the mechanical ventilation code. They basically rewrote that document that became then the code applicable for all new construction. And that was relabeled to being Standard 62. Standard 62 was then rewritten in basically 75 and rewritten in 1980 that and in that area it became the document that guided all new usage of ventilation air in public buildings. Now, that document did not include industrial sites. So simultaneously to this development, the Instrumentation Society, along with TAPI, which was the Technical Association for Pulp and Paper Industry, had developed their own standard for indoor environment in control rooms that were exposed to the problems of corrosion. And so with these documents in place, what we have is the basis for what we went on and developed on through the rest of the decade. The full instruction manuals, training documents, and a full range of codes and standards that we'll dig into a little bit in more detail next time round, because we want to break here and give us a chance to look at some things that will further refresh our current understanding of where we are with indoor air quality. So let's take a break from this, because we need to go ahead later on, perhaps in another session, deal with more of these standards and incidents and controlling drivers, so that we understand where we're at with the current indoor air situation.
Absolutely, yeah. And Barney, obviously there's more to the story, as you mentioned, for the IAQ learning curve. So would you be willing to schedule another event to finish the story?
Oh yes, we can go ahead with this, because there's much more that we need to address to bring us to the 21st century. None the least of which we want to talk just a few minutes before we depart about what the role has been for this very building. Where Pure Air fit in to this entire story of bringing indoor air quality to full closure, both industrially and commercially.
All right, awesome. So, and while we schedule that event, in the meantime, would you be willing to develop like a bibliography of the noteworthy standards and documents that you referenced?
Yeah, I'll put together a compendium listing of the important ones that influence greatly both an understanding as well as the training and procedures for resolution.
Okay, excellent. Now, we do have a few questions that were submitted prior to the webinar. So we have 3 questions. We'll answer these questions before we get into the request people online to ask the speaker, Mr. Barney Burroughs, any questions as well. So the first question that was submitted was, what are some signs that a facility's IQ plan looks good on paper but isn't performing as intended in actual practice?
I think without being a smart aleck about it, the truth be known, that happens most times.
Hmm.
It is not unusual that such a situation would happen. And one of the best signs that things are not working well, um, that were originally approved and looked great on paper, but isn't happening in situ, is complaints. Um, and complaints can be complaints about the performance of equipment. It can be complaints about the resulting environment, the um, how how things are working, and those kinds of things. So very, very high maintenance requirements, high energy usage. So all of these factors are clues that the intent has not been fulfilled. And oftentimes this is brought about because the facility is not properly commissioned to begin with. And one of the values that ASHRAE brought early on was the process of structuring the commissioning process to, in a sense, demonstrate to incoming building users as well as the owners themselves that the intent had been fulfilled by the contractors. And so that the equipment selection, the equipment installation, and the equipment operation is being fulfilled properly as intended. And so oftentimes a fix of something of this sort is to actually re-engineer the commissioning process and to either to do it over or to actually put it in place to begin with to bring the facility into proper behavior.
Okay, awesome. Thank you. Thank you for that answer. All right, second question. Are there parts of the world that should worry more about indoor air quality than others?
Oh, well, yes, because the world is the world and it's different. But with the knowledge that air quality is basically a combination of both contaminant control and dealing with environmental conditions, you would think that areas such as Singapore, for example, which has extremely high relative humidities in its ambient air, would want to be very careful about moisture management and controlling indoor relative humidities um, as opposed to being in the Sahara Desert, which would not have that problem of relative humidity. It would definitely, however, have a severe problem because it is renowned for its desert storms that will literally dump tons of airborne dirt and sand in urban areas, sometimes even overnight. Beijing, China, for example, is plagued with dust in its streets, accumulating nightly from the Gobi Desert. And it is a daily phenomena to have to basically sweep the streets and clear it of thousands of pounds of dust that has accumulated simply in 24 hours. So yes, there are divergent areas that need to pay a different kind of special attention to the air quality because of the external air quality to begin with as being one of those issues that I alluded to earlier about the misconception of where the air's been.
Right. Okay. All right. So last submitted question. So For facility owners or managers starting to take an IAQ more seriously, what would your top three advice items be on the first steps?
The truth matter is, I think this question most directly focuses on how to fix the problem, with the assumption that time has elapsed, building has aged, equipment is older, there has been delays in maintenance. So deferred maintenance and deferred asset management have been at play. And to step in and to bring that building back to top performance is a combination of improved air quality, improved energy management, improved equipment performance, and general maintenance of the building. So those in a sense would be on the checklist of things that need to be addressed. But very, very early on, the first thing that would happen is to start from an operation and maintenance standpoint, um, a concept I call by a simple acronym, MBWA, management by walking around, meaning operation managers walking the facility and doing something about obvious shortfalls, obvious maintenance issues, obvious cleaning issues, obvious maintenance issues, and those things that are most apparent and most easily taken care of if the action is taken, and meaning take the action. Because in many instances, these issues are allowed to defer, therefore accumulate, therefore increase in severity, and in the long run, costing a great deal more money to replace or upgrade or undo unintended consequences from delayed maintenance. And the management by walking around is a way of constantly being aware of your building deficiencies and being able to act in anticipation rather than reaction. That can cost more in terms of both delays, productivity, and replacement equipment.
All right. Excellent. All right. So that was the submitted questions. So now we're going to open it up to the attendees. Anyone has any questions for Mr. Barney Burroughs, His Eminence? Any questions? Or request to chat? Give it a few minutes or a minute, otherwise.
Let me do just a time filler until we find whether there are any additional questions that folks might have. So that is that I think it is important for our listeners to hear that Pure Air as a company has been part of this story, because the leadership team of Pure Air were part of the latter years of the growth that occurred leading up to and spanning the millennial change. That means that the management team here has been subjected, as was I, to that history, and responded by focusing on what they felt were really, really important parts of the need of building owners and of industry. And one of the things that they have done is take the very best of equipment concepts in terms of scrubbers. They have not only taken the best technologies in terms of control technology, in terms of sorbents and filter modules and equipment, they've taken the best of it and then gone a step further because they've developed patented products that address specific contaminants. And so not only have they taken advantage of the strengths of well-established products, including the original patented chemisorbent that started back when I held it in my hands, to the proper blending of different components of the chemical spectrum that's available to them. So they have added chemistry technology, they have added manufacturing capability, they have added that to containment and power uniqueness and capability, and have put together an extremely competent and extensive product line that can address every aspect of both the gas phase and the particulate contaminant control things that they find with their customers. And their customers are basically worldwide in terms of the needs, because they're solving problems here in the Southeast, here in the state of Georgia, from here to Saudi, and from here to China and Malaysia. And so their capabilities have been brought about by virtue of the strength, the technology, the competency, the effectiveness, both performance and cost effectiveness of their product line. And so that speaks for itself in terms of the success that they've had, both as a company, but also as a basically a leader now in the whole industry of air cleaning and filtration.
Right.
So I commend Pure Air. They have, in a sense, taken the concept that I started in 1967 to full fruition, to the benefit of both industry and commercial marketplaces. So I commend them for, in a sense, fulfilling the task that I left undone.
Marty, thank you very much for that. And yet no other questions arise. So with that, we're going to go ahead and end the webinar, but we want to thank everyone for attending. Thank you very much. Video will be available shortly. Again, thank everyone, and Barney, thank you as well. I'm looking forward to having you back to continue this learning curve.
Thank you.
Thank you, sir.